Hello students, in the last class we were discussed about class 10 first chapter named real numbers, exercise 1.1, 1.2 and 1.3. Today we will discuss about exercise 1.4. Okay, exercise 1.4 first question is, without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or non-terminating repeating decimal expansion. Means in question number 1, there are 10 questions given. Now we need to say about their decimal expansion. Before starting question number 1, you should know about rational numbers decimal expansion. About rational number decimal expansion. First condition is rational number decimal expansion may be terminating. Terminating meaning completed. Okay. See, if we divide 10 by 2, 2 5s are 10, no remainder. Or if we divide 15 by 2, then 2 7s are 14, 1 give decimal point, 0, 2 5s are 10. See, 7.5, that means no more step left, means remainder is 0. So it is called terminating decimal expansion. And point number 2 is a rational number decimal expansion may be terminating but non-terminating but repeating. Non-terminating meaning not completed. Okay, see, if we divide 10 by 3, then 3 is a 9, 1 give decimal, again 3 is a 9, again 1 or not, and so on. Okay, that means if we divide 10 by 3, then the quotients are 3.33333. It is called non-terminating but repeating. Okay, both are the properties of rational numbers. That is called non-terminating but repeating. Okay, non-terminating but repeating or recurring, same word. Now in question number 1, there are 10 questions. All questions are in fraction. We know all fractions are rational numbers, but just we need to write about their decimal expansion. That means we have two options. First option is maybe terminating, or number 2 non-terminating but repeating. Okay, now question is when a rational number decimal expansion is terminating. See, 3 by 8, one example. Okay, example 3 by 8. Now 3 by 8 equal 3. Now factorize 8. 8 2 4s are 2 2. That is 2 into 2 into 2. Okay, now 2 into 2 into 2. 2 how many times? 1 2 3 times. So multiply 5 3 times. And similarly at the numerator place, 5 multiplied 3 times. Then see, 2 into 5 10, 2 into 5 10, 2 into 5 10. That means 10 how many times? 3 times. Again 5 5 is 25, 25 to the 1, 25 into 3. Then 100, sorry, 10 10 100, 100 10 is 1000. And 3 25 is 75, 3 1s are 3. Then the answer is 0.375. Now see, the denominator was 8 and we got 0.375. It is depends on this one, 2 2 2. Again one more example. If 5 by, okay, different example, 7 by 50. 7 by 50. Then factorize 50. 50, 5 10s are 5 2s are. Then 7, here 2 how many times? 1 time. 5 how many times? 2 times. Okay. The next line, see 7 and here 2. 2 how many times? Only 1 time. 2 5s are 10. That means for the next 5, 1 more 2 required. So write 2 2 times and 5 2 times. We add 1 more 2. So write at the numerator place. Now 7 2s are 14. Then 100 and answer is 0.14. See, at first fraction 3 by 8 8 factors are 2, 2, 2. Again, second fraction is 7 by 50 and 50 factors are 2, 5, 5. And both fractions, decimal expansion is terminating or not. That means if a number factors are in the form 2 to the power n into 5 to the power m, and m meaning any non-negative integers, okay, then that number decimal expansion is always terminating, okay. If a number has more factors other than 2 to the power n and 5 to the power m, then its decimal expansion is non-terminating but repeating. Clear point? Again, if a number denominator, I'm saying about denominator, okay, if a number means q value, q factors are, q means denominator, q factors are 2 or 5, 2 may be 100 times or 5 times or 1 time, and 5 may be 1 time or 50 times, okay. 2 to the power n means 2, n means any non-negative integers, 5 to the power m, m means any time, okay, means any non-negative integers, then that number decimal expansion is terminating, okay. If more factors other than 2 and 5, like 2 into 3 into 5, see in this number 2, 5 and 3, one more number is included or not, 3, then its decimal expansion will be non-terminating but repeating, okay. Now question number 1, exercise 1.4, question number 1. Question number 1 is 13 by 3, 1, 2, 5. Now we need to say about its decimal expansion. So a first factor is the q value, q meaning denominator. 5, 6 is 30, 1, 5 2 is 10, 5, 5, 25, 5, 1, 25, 5, 25 and 5, 5 times. See, 13, 5 how many times? 1, 2, 3, 4, 5, 2, 3, 4 and 5. That means 13 by 5 to the power 5. 5 times. Already I said if a number q has 2 to the power or q in the form 2 to the power n and 5 to the power m, then its decimal expansion is terminating. Now here no value meaning 0 and 5 to the power 5, see they are in the form 2 to the power n into 5 to the power m, so its decimal expansion is terminating. Therefore its decimal expansion is terminating. If question is why, then your answer will be because q means denominator in the form 2 to the power n into 5 to the power m, 2 to the power n into 5 to the power m. Clear point? Okay, one more question. Question number 1, Roman number 7. Roman number 7 is 129 divided by 2 to the 2 square 5 to the power 7 into 7 to the power 5, 7 to the power 5. See here no need to expand, already given as a factor. Now see, observe the denominator means q value 2 yes, 5 yes, but one more number 7 is included or not. So we can say here q has more factors other than 2 to the power n into 5 to the power m. So its decimal expansion will be non-terminating but repeating. Its decimal expansion is non-terminating but repeating. Why? Because q has more factors other than 2 to the power n into 5 to the power n. Because Q has more factors other than 2 to the power n into 5 to the power n. Clear? Similarly, you can solve the rest problems. Okay, now proceed to question number 2. Question number 2 is related with question number 1. At first, read the question. Write down the decimal expansion of the rational number in question number 1 above, which have terminating decimal expansion. Write down the decimal expansion. See, question number 1, Roman number 1, answer was its decimal expansion is terminating. We know its decimal expansion is terminating, but question is, now question number 2 is write down the decimal expansions of those rational numbers. Means its decimal expansion is terminating, so write in decimal. Okay, see, let me explain. 13 and here 3125 already factorized. 5 how many times? 5 times. So 13, 5 to the power 5 and 5 times, so 2 multiplied by 5 times, but both side. Okay, now 5 to the 10, so 10 to the power 5 and 2 5 times meaning 32 multiply with 13. 3 to the 6, 3 to the 9, 1 to the 2, 1 3 to the 3, and 6, 9 to 11, 3 1 4. That means 416 by 10 to the power 5. Then 416, write in decimal. 10 to the power 5 means give decimal place before 10 digits. 1 2 3 4 5. Give one more decimal. This one is the answer. See, it's your heart. See, at first factorize the denominator, because 3125, its factors only 5 to the power 5 means 5 times. So 2 multiply 5 times. If 5 is 2 times, then 2 multiply 2 times. Okay, because 5 2s are 10. We want 5 2s are 10 pairwise. 5 2s are 10, again 5 2s are 10. Now 5 2s are 10 and 5 times, so 5. And 13 multiply with 2 5 times. Answer will be 416. Now 10 to the power 5 means give decimal place before 10 digits. Okay, similarly you can solve the rest problems. Now question number 1, Roman number 8. See, it's 6 means 3 into 2 and 50 meaning 5 into 3. See, always factorize both numbers, numerator and denominator both. Okay, see, why? If Q has more factors other than 2 and 5, then its decimal expansion is non-terminating or repeating or not. But in this question, see, we can cancel 3 with 3. Then see the answer 2 by 5. Is there any 3? No. So its decimal expansion will be terminating. So factorize the both numerator and denominator. Now 2 by 5, its decimal expansion is terminating. But according to question number 2, so now change the question number. You can write as 2 Roman number 8. Write its decimal expansion. See, 5 how many times? 1 time. So 2 multiply by 1 time. And same 2 multiply with the numerator. Then answer is 5 to the 10 and 2 to the 4. Then 0.4. That is your answer. Okay, now proceed to question number 3. In question number 3, there are 3 questions. Question number 1, 2 and 3. Now, the question is, the following numbers are rational or not. Already you learned about rational number decimal expansion. If a number decimal expansion is terminating, then it is called rational. Or if a number decimal expansion is non-terminating but repeating, then it is called a rational number. Now, which questions are satisfying these conditions? At first, question number 1. See, 43.123456789 completed or not? That means terminating. Its decimal expansion is terminating. If decimal expansion is terminating, then it is called a rational number. Therefore, it is a rational number. Clear point? Now, Roman number 2. See, 0.120, 1200, 12000. See, 120, 1200, 12,000. That means 120 is not repeating. So its decimal expansion is non-terminating, but non-repeating. But see, this one meaning non-terminating. So Roman number 2. This question decimal expansion is non-terminating and non-repeating. This is not rational number property. Therefore, we can say it is an irrational number. Okay, irrational number. Irrational number. Why? Its decimal expansion is non-terminating and non-repeating. Now, about question number 3. See, 43.123456789. See, this simple meaning bar. That means repeating. Okay, it's non-terminating but repeating. Therefore, it is a rational number. It is a rational number. Rational number. Now, again, question number 1. See, if rational, then write about its decimal expansion. Write about its q. Q meaning denominator. See, if a number decimal expansion is terminating, then q is in the form 2 to the power n into 5 to the power m. Here q is in the form 2 to the power n into 5 to the power m. Now Roman number 3. Again, Roman number 3 is a rational number. Then write about q. Then q has more factors. Q has more factors other than 2 to the power n into 5 to the power m. Why? Because its decimal expansion is non-terminating but repeating. Therefore, its decimal q is in the form 2 to the power n into 5 to the power